Hello and welcome back. I'd like to talk to you guys about L'Hopital's rule. This was invented by L'Hopital himself, and it tells us that if we have a limit that gives us something in the form of 0 over 0, or infinity times 0, or infinity divided by infinity, we can use this rule. And let's use this rule. I also forgot to say it can also help us with things like infinity minus infinity as well. So this first limit, it's a pretty famous limit actually. We use it a lot for some reason. I'm not sure why, but that's what my professor said. Now we know that sine of 0 is 0 and 0 is 0, so this is 0 over 0. But L'Hopital's rule tells us we can do, so we can take the derivative of the top and the derivative of the bottom, and the limit will be the same. So let's do that. This is the limit as x approaches 0 for cosine of x. What's that equal? Well, that equals 1. Easy. It's got to be one of my favorite things. This one, infinity over infinity. L'Hopital's rule. Let's do it. Let's derive the top. What's that going to be? Well, that's just going to be 1. What's the bottom? That's just going to be 3. So this is going to be 1 over 3. Beautiful. I just love this rule. Now here's a funny one. Infinity minus infinity over infinity. L'Hopital's rule. Let's take the first derivative. E to the x is just e to the x minus 8x over e to the x. Infinity minus infinity over infinity. That's another indeterminate form. Let's do it again. Limit as x approaches infinity, e to the x is just going to e to the x again, minus 8 over e to the x. Infinity over infinity again. Let's do it again. E to the x over e to the x. What's that going to be? Well, you might say infinity over infinity, but what's e to the x over e to the x equal? Anything over itself is just 1. 1. Now there is cases where L'Hopital's rule might not work. For example, some trig ones it might not work because you'll fall into a loop. But a lot of the time, if you've got something like a polynomial term that's giving you trouble, it's probably going to work for you. And you guys can go plug these into your graphing calculators or whatever you have, and you'll see all of these limits. They really do work. And sometimes it takes a few steps. There's also some cases where you might have to take e to the ln of your original function and then, bring it across, bring it down and all this, and then take the derivative, but it works. It works very well. And make sure you always have to have a fraction, because let's say if I tried to use it for the limit as x approaches infinity for, say, x squared, which we all know is just going to be infinity, but let's say I tried to use L'Hopital's rule on it and said limit as x approaches infinity of x squared over 1. Well, if I try to derive 1, I'm just going to get 0. And that's another indeterminate form. I can't really do it, so just remember when you can use it. It's going to be a lot of the time. It's going to be of great help to you. I know it was great help to me, so good luck with this. Thanks for watching. See you in the next one.